Hey everybody, this is going to be a walkthrough of evaluating LabVIEW through the lens of Project Euler. Now, Project Euler, as I can pull up here in just a moment, is a very interesting project that proposes that you learn how to do things with languages and math by being proposed or being presented with a variety of individual questions. Now, in terms of there, it looks like there's 946 possible questions, but we're going to start out with number one right here. And so, what we want to do with this project is look at LabVIEW, look at the constructs of the language, and things that I will use in the process of trying to figure out the problem, either on the block diagram, the front panel, the palettes, and so on. So, this is going to be a bit of a running process of learning on the fly that you get to see, and let's see how it turns out. So, let's go ahead and start with problem number one. Okay, so what we have is our very first question. We have if all the list the natural numbers below 10 that are multiples of 3 or 5, as you can see, kind of teasing apart the problem here. These are all the multiples of 3 or 5 that are less than 10. And so indeed, we want to be able to add them all up to get the end value. So go ahead and do that same thing for all values below 1000. So we're going to brute force this with some LabVIEW. And so let's talk through some of the shortcuts that I'm going to use. I'm going to press Control N, which, as you can see up here, is the ability to create a new VI or a new program in LabVIEW. And when we do that, we're going to see a front panel and a block diagram. Of course, the block diagram is our code, and the front panels are our controls and indicators. So the first thing that I want to toy with here is the idea of, hey, how do I go through and what's the math that I use to figure out is something a multiple of it? So there's a lot of different ways that you might think is the right way to go ahead and figure out is something a multiple of another number, but I know that the twist is using the modulo math or quotient and remainder, because if you were to use this quotient and remainder instead of like I could divide by basically there's a couple different ways that like I could think through, like I could take both numbers, whatever number I'm on, divide it by 3 and see is there anything after the decimal point, right? There's a lot of different weird ways you could kind of fake into existence is something a multiple. But really, the best way to do it is the modulo math or quotient and remainder in LabVIEW. I'll press Control H to bring up my context help, or you could also click on the question mark up here in the upper right hand corner. That is the way of kind of showing or hiding that window that allows you to hover over something and say what the context of your cursor is hovering over. So I've got quotient and remainder. And what this is going to give me the ability, actually, let's go ahead and play with it. So I'm going to right click, create all controls and indicators, basically creating all variables for the inputs and outputs. And you can see on the front panel there, I've got my X, I've got my Y, I had to rearrange them a little bit. And then my quotient is on the bottom and the remainder is on the top. So there we go. So if I were to take the value of 5 and divide it by 3, you'll see that I have the denominator is 1, but I have a remainder of 2. I know that that is not a multiple because this is a non-zero number. There's numbers left over after the divising. So if I were to take the number 6, however, you'll see that this now goes to 0. So anytime that I want to do this, well, let's see, how could I even experiment with this math a little more? Because one thing that you'll notice is that every time I'm changing it and I want to run my program, I'm coming up here and hitting the run arrow, or also I'm hitting the Control R key combination. On Mac, I think it's like operate or whatever it is, R in any case. So there's a nice thing in LabVIEW that you can do with the run continuously, which is this kind of circular arrows that allows me to very quickly go through and now I can kind of move these values around and you can see how things operate without having to run the program over and over again. So instantly we have a program that is running over and over again that I can work with my values and see the response. And now we can very quickly see, this is what's happening. Now, this tactic of run continuously, very helpful for prototyping, working with algorithms, not the way to create your end application, but it is a great way to experiment with a single function or a single program or kind of a sub function, if you will, subroutine that you want to test over and over again. You can click that button or the stop arrow or the stop button to stop it. But very clearly, we know that we have something that is a multiple of a number if this value indeed equals 0. So how do we detect whether or not that equals 0? So I'm going to go ahead and get rid of those indicators. And we'll actually we're going to go ahead and leave them there for the moment. Within LabVIEW, there is something referred to as the comparison palette. Now let me go ahead and get out of here. And you're going to see up here that we have this palette that is the comparison palette. And underneath here, you'll find a bunch of functions that allow you to indeed do the evaluation of greater than, less than, equal to, empty, on and on and on. I suggest that you go ahead and look through this comparison palette. But obviously for what we want to compare, we want to see is something equal to 0. Now, indeed, you could drop an equals and you could drop a constant for the value 0 and things like that, but this is basically, with very little effort, giving us that same capability. Now, a new thing that I'm going to operate and show you in LabVIEW is also, if you start the process of wiring a terminal, as it was on this equals then node, and I wanted to see what the value output is of it, I could start wiring. I can right click and say create indicator. Now that gives me the ability, now I can see on my front panel, now instead of evaluating based off of a number here, I can see whether or not that same exact tactic that we were looking at before, whether or not a value indeed is 0. And this is going to become very, very valuable in a very short period of time. So now I'm going to go ahead and stop that. So now I know that I can figure out, is any specific number between 0 and 1,000 indeed into a multiple of any number. But now what I want to do is kind of scan across all of those. So I'm going to drop something called a for loop, which is, once again, a for structure or for construct in any given language. I'm going to drop that and drag it around it, that specific formula. Now what I want to do is I'm going to go ahead and do this with, I want to find out, this is kind of the, let's see, the root number. And then this is the number to evaluate, eval. And so now I can go ahead and actually get rid of these numbers because I don't care about that as much. I just need to make sure that I can add up all of the numbers that meet that criteria. So now what I'm going to do here is actually say, for the n indicators, how many times this for loop runs, I'm going to put it to 1,000. This is going to run from 0 to 999 in terms of what we've got there. So now I'm going to take that number to evaluate. I'm going to delete that and put the root number. Now, some of the things that you may have noticed as well that I'm doing, in order to delete this function, I use a nice little hack that you can do. Instead of having to take my hands off the keyboard and the mouse, I can leave it there and just press Control X as a way of kind of, cheating into existence the deletion of something merely by cutting it to the clipboard. Now I'm going to go ahead and wire this in, and I'm going to press the space bar to actually change the direction of my wiring. Now you can see that it wired as indicated, but I still have this broken wire that was left over or left behind. I can use I think it's Control B, remove broken wires from selection, or remove broken wires. I can press Control B and it gets rid of the broken wire that's there. So now if I let this run, you might see, you didn't see anything happen. Well, it ran so fast, we weren't able to tell this flickering on and off, or what numbers we were on. So what I'm going to do is actually go through and, using that same trick, I'm going to go ahead and create an indicator off of this wire, right click, create indicator. And we're going to see it run. It's going to run so fast you can't even tell. So we're going to put an artificial delay in our program. So let's go ahead and I'm going to use a, you can see this wash up here for the timing palette or the timing functions. I'm just going to click and drop the wait millisecond. I'm going to go ahead and click, drag, right click, create a constant. I'm going to wait for something like, 25 milliseconds. That is the number of milliseconds I wish to wait. Now when I go back and I press Control E to see that front panel, you can see that up here at the window, create show front panel. So now I've got the ability to show that front panel. Now as I run this, it should flicker a little bit more as I go through all the numbers. And so hopefully you can see that it's running at a relatively slow rate. Obviously we don't want to run that whole time. We could speed this up quite a bit. Once again, it ran all near instantly with no delay, but let's go ahead, so it's maybe 1 millisecond. There you go. So now that was, we were able to calculate all those values, but we didn't actually add them up. We didn't do anything. So how do I take all those numbers that meet this condition and start to add them up? Well, I'm going to take advantage of a really great feature within LabVIEW, that is the auto indexing within a for loop. So merely by taking that output, and every wire is basically a variable, now we've indicated to the for loop that I want to take all of those numbers and I want to add them, basically build and a list or an array of the output. And in fact, that's not the number that I'm looking for. It's, I want to add all the numbers that meet that criteria. So there you go. So I've fixed my first bug. I wasn't looking at the right ones. So now this array, if I were to go ahead and create an indicator for it, let's go ahead and resize that front panel a little bit. This should really just be a list going from 0 to 999, which doesn't give us very much. However, we also have the ability to filter what is actually indexed into this array or list on the output conditionally. And it's such a great, beautiful feature that we can right-click on a tunnel coming out of a structure. We can change a variety of things in terms of, is it indexing by default? Is it just showing you the last value, concatenating? But what we want is this option right here, which is different. It's conditional. And so now, anytime that this value is true, it's going to only add to that list at that point in time. So now you can see these are all the integer multiples of 3. Now it's also including 0, and we don't want that. So there's a couple different things that we can do to index out that when you have the value 0 divided by 3, the remainder is 0. That's not exactly what we're looking for. And so how do we negate that first value? Well, we could just always know that the first value is going to be 0. It's always going to be bad, and we don't want that. And so let's go ahead and use an array primitive to go ahead and say strip that off. We could do some more Boolean logic in here to say, well, make this value, you know what, let's go ahead and do that. There's a couple different ways to skin this cat. Let's go ahead and just use something else within LabVIEW that's very useful, and it's called first call. And if I'm not mistaken, I believe it's underneath the synchronization palette that we have right here, and we have this first call primitive. So the very first time that this VI, this function is called from within this VI, this is going to return indeed a true. So what we can do is say that, well, when I'm going to negate that, so when it's not the first call, I'm going to bring up something called quick drop, which is another also very useful tool that allows you to just, if you know the name, like not, it will give you that specific primitive instead of going through and navigating the palettes. In this case, I would go to the Boolean palette and find my not primitive. And then what I'm going to do is actually using that Boolean palette is I'm going to say if it's not the first call and it's also equal to 0. Now that is going to be my criteria. I'm going to use that same cut. I'm going to double click that wire, which is going to select a couple segments of it instead of a triple click, which gets it all. Press Control X just to delete it. And now I'm going to only add an element to the array when it is indeed integer multiple of root. All right, let's make a little bit more room here. Let's lay the diagram out. And now when I go through and I run this VI, you're going to see very quickly that we are going through, and indeed, there we go. Now we have our list, 3, 6, 9, on and on. I'm going to go ahead and actually do a couple different things with the front panel. I want to see all my values, and so I could guess how many are here. I could technically move my cursor into that zone, and I can actually put it all the way to the right, and now the blinking insert cursor, and I can actually press up on my keyboard and hold it, and I can scroll through those values. Or what I can do is I can do visible items and vertical scroll bar. And now I can move through the elements of the array, reviewing them by seeing that I have indeed a scroll bar down here, and I can see that I'm going to 999 and no further. Very useful way of leveraging the user interface, the interactivity that you get after the program's already run to go ahead and look at your data sets. Now, what do we need to do with this? Well, now we're going to go through, and if we wanted to add up all of these values, there's another great feature within LabVIEW that is add all array elements. So we're going to go ahead and go to the numeric palette that you can see up there and right here. Now, this is a unique feature, and this is really great to highlight. There are a lot of features and functions that exist in LabVIEW because we're so used to using LabVIEW as a purpose-built programming language to work with data and signals. So we've got more functions than what you're used to. So please don't not scan what's available and recreate functions that are already there as effectively primitives within the language for you to call. So this is one of the great ones that we want to use right here for indeed add or sum all of the array elements, hence the large sigma. So now if I were to go ahead and put that in there and create an indicator off of it, let's go ahead and do that. You'll see that this is now my sum. I'll go ahead and move it around. And now if I double click on that terminal, you'll see on the front panel that we've got there, There you go. So that is now the sum of all of the integers that are indeed multiples of 3. Now, it said I need to do this for 3 and 5. So there's a couple different things I could do to try to make this all work within one loop, but this is a great opportunity to highlight the power of the simplicity of doing things in parallel within LabVIEW. So instead of actually trying to make it all happen within one loop, I really will simply duplicate this. By selecting my section of interest, I did a control-click drag, and now I have 2 root numbers, which I can go back to my front panel. I can go ahead and get rid of some of these superfluous indicators because they're not necessarily providing value for where we're at to simplify my front panel. I don't need to see the index on the front panel either. But now I indeed have my 2 root numbers. So 3 and 5. Now I also have to, let's go ahead and evaluate the outputs within there. Actually, we can go through and we can, let's just duplicate this chunk right here. And I duplicate it. We're just going to run it again just to kind of evaluate, did things work the way that we thought they were? Do we have a bug? So I'm going to go ahead and you can see that we're already have fewer items. Let's scroll up there. And indeed, look, we've got our 5, 10, 15, 20, on and on. So now we have the ability to go through, and honestly, the funniest thing is I probably could have left that first value because it was a value of 0. But for all intents and purposes, I'm trying to show that we had multiples of 3, 5, 6, and 9. So I wanted to make that the same. I didn't want to include that 0. Sorry, a bit of a non sequitur there. Just realizing I didn't have to do all the things that I was looking to if the purpose was summing up all my values on the other side. But now we've got our value, and we indeed have a sum, and indeed it is a 5 or a 0 on the end, so kind of a quick sanity check. And so now both of these things are indeed running in parallel. So now we're going to go through, and let's go ahead and take both of those sums. And now I'm going to go ahead and use that quick drop again and just type in add. Very simple. Take that, wire it through. Oh, that's not what I was looking for. So this gives me a great opportunity to highlight something else in LabVIEW that's very useful. The ability to insert something on a wire. Because if you didn't have the ability to insert, you'd have to probably get rid of this. You can use something on the panel that you've already got or the block diagram that you've already got instead of going back to the palette and done that. But instead, I'm going to go through and actually insert on the wire. I can right click and go to insert, and I can start to scan the palettes from here. So from here, I can go to the numeric, add array, voila. You can see that we now have the add primitive can take either, you actually just a moment ago, you saw it was taking an array and it was adding that singular value to every element in the array. And now we also have the ability to just automatically morph or transformed into just adding 2 integer values together, for which now I'm going to go through and take that sum output, go here, get rid of the information I don't need, like that array, run the VI, and now I have a value. Now I believe this value to be very likely correct. So let's go through and copy it, come back over to here into the Project Euler. I'm going to paste it onto the screen, and I'm going to check to see my results. Let's see if I did it right. Ooh, sorry, but the answer you gave is incorrect. So let's go back and figure out what I did wrong. Go back to problem 1. I'm actually kind of surprised. So 3 or 5 below 1,000. I think I know what the problem is here. We have some duplicates within both of those. So our problem of actually going through and determining whether or not this is correct was too much. So now it looks like we need to go through, and maybe it makes sense to put them into the same loop. Or we could go through, and before we actually add up all of these elements, we could figure out which ones are actually duplicates. So we could go in a variety of different routes. I think for the sake of time, I'm going to take that logic and actually just put it within the same loop. So let's go ahead and do that. I'm going to use, once again, things that exist on my code already as a way of just kind of copying it forward. Now I'm doing both of those operations. Now, indeed, both of these primitives are operating in parallel. Let's go ahead and get rid of some of the code that we know we're not going to use anymore. Another thing that's pretty nice within LabVIEW is you can actually, if you like the fact that this is wired, instead of deleting that and having to rewire things through, you should be able to right-click, remove, and rewire. And that will retain the wire values, or sorry, the linkage between a wire and a node, which should save you a good deal of time. So now the twist is, let's go ahead and do this. plumb that through. And now what I'm going to do is I'm going to insert an or on here, because I want it when if this or this are equal to 0, then it is a qualifying value. So let's go ahead and do that, but instead of doing the right click and insert, I'm going to use a different tactic too. I'm going to create the wire and press Control Space to bring up Quick Drop. Now, once Quick Drop is open, I can type in what I would like to insert, in this case, or. But before I do anything else, I'm going to press Control-Shift-I. Control-Shift-I is going to give us the ability to just insert that thing onto the wire itself. And now you can see that we have, indeed, our function working. Now let's go ahead and try this again. There's a brand new number. It's clearly smaller than what we had before. My inference of we've got duplicated numbers, which we know exists. Let's go ahead and come into here and try it again. Paste that value and check it. And with a little bit of effort and a little bit of waiting, hey, we've got it right. So we've answered our first problem within LabVIEW. I think that the simplicity of what we've got here was very clear. And there's a lot of things that we looked through in terms of working on the diagram, working with the nodes, working with the palettes, working with the structures, and even functions and capabilities that even if you're a LabVIEW programmer already, you might not have even realized. Once again, the adding up all of the values within an array, absolutely something you could have done manually instead of using the primitive. The ability to use this conditional terminal, absolutely something you could have added up yourself. The ability to go ahead and do this all in parallel. Also, many different ways that we could have gone through this entire process. And although our math that we were looking at just a moment ago up here indeed gave us the right value in terms of the sum, indeed, there's even an easier way within LabVIEW to go ahead and do that, where we start up here by creating a ramp pattern, basically all numbers from 0 to 999 as an array. The reason this matters so much to us as LabVIEW programmers is so frequently we're working not just with single point information. We're working with arrays of information, time series information, data that you have sampled from a data acquisition device, everywhere from DC values all the way up to RF and beyond. And so if we have a language that adapts very well towards working with these large arrays and data sets as a first-class citizen, why not take advantage of it? And so one of the things that you'll see here is that I've built an array of those numbers, and that polymorphic function, which is not exactly the right way, but you can see where the function adapts to an array on one input and a scalar value on the other. And then it outputs basically an array doing that specific operation, for which we can put it into our Boolean operation, into our OR operation, and on and on. And you see how this cascades down. And really, we could stay operating on an array, except we don't have really a function that allows you to kind of filter out elements in an array based on a Boolean string. So I still had to go back to a for loop to very quickly do this operation. But now you can see very easily that we're going through and we're indexing, auto-indexing, basically for each element in this array, for each element in this array, conditionally indexing back out the right elements. And so you can see that our program up here indeed is functional. It does what it needs to. It deserves a little bit of cleanup, but is this program down here more practical and also even a little bit cleaner in terms of what we've got? Still yields the same result, but now we're operating on blocks of information and blocks of data. And in some cases, depending on how this operates, this could actually be significantly faster, depending on how large the memory sets are or how you need things operating. So always be thinking in the back of your mind, hey, even though I've solved my problem, is there a way to deal with it or work with the primitives? So instead of doing one point at a time each iteration, can we take advantage of what LabVIEW can already do, working with arrays of information to do that manipulation and see how much further that gets you? All right, so if we were to go through this, what are all the things that we looked at? Well, we looked at indeed being able to navigate the palettes, being able to leverage the structures, the data types, the polymorphic nature of many of our functions, the ability to do, once again, work between numbers, be they integer or floating points or booleans, and leveraging features that exist in terms of our structures. In this case, we were looking at the auto-indexing capabilities of our for loops, and then also the ability to do conditional indexing of those outputs as well. And I hope that got you further along understanding this very first question, although this did take me almost 25 minutes to go through. Hopefully that gave you so much of a rich evaluation of what LabVIEW is capable of doing to go through and do just even one of these simple Euler problems. Thanks.